Hey guys, so this is the last section of Unit 7. Just to give you like kind of a heads up of where we're at. We're on day 3 of week of March 2nd. Next week, you will have day 1 a review day and day 2 a test. And then day 3 next week, one of the classes is going to be on a physics field trip that day. Okay, so this is what the future looks like. Let's wrap up chapter 7, solving trig equations. So this first, solving basic trig equations, we've covered this before. How do you solve this? Well, you can do it 2 ways. One way is looking at the unit circle. So if I want to know where sine theta is 1/2, where does that happen? Well, sine theta is 1/2 at pi over 6, or 30 degrees, or 5 pi over 6, 150 degrees. And generally speaking, when we solve these, it will give you a range restriction. So it might say 4, 0, 360 degrees, right? It might say that, in which case you would say the answer is 30 degrees and 150 degrees. Okay. If I wanted all answers, you could say 30 plus 360k, or 150 plus 360k, right, where k is an integer. Okay, makes sense. So generally speaking, it'll give you a domain restriction, or if it wants all answers, you just put both and add 360 degrees, or add 2 pi. Okay. Cosine theta, where is it? Negative root 2 over 2. So again, you will not be given a unit circle on your test, but you can fill out a blank one. Where is this true? Well, this is this is happening at 3 pi over 4, or 135 degrees, or 5 pi over 4, right? So maybe this would say for 0, 2 pi, and so you would say theta equals 3 pi over 4, and 5 pi over 4, right? All answers, you would just add 2 pi k, okay? And then tan theta is 2. Now, this is not on the unit circle, right? What does that even mean, tan theta? To like, how do I find that? Remember that sine are horizontal lines, right? It's basically saying y equals 1/2, and cosine these are vertical lines, like x equals, negative root 2 over 2, right? That's how you find those. But for tangent, that's a slope. So it's basically saying for what values does the slope of a line, for what values does a line with slope 2 intersect the circle here and here? That's the question. And that's not on our unit circle, so that's something we would find using the calculator. Let me change this to something that will work. Or you can use, well, if you wanted it, make sure you change it to degrees or to radians, whatever you want, and you would say inverse tan of 2. So roughly 63.43 degrees. So if it was between 0 and 360, you would say 63.43 degrees, and the other value is 180 degrees on the other side, so we just add a 180 to that, and it would be 243.43. Okay, so these are pretty straightforward, right? You've done these before. We talked about this, taking the inverse trig functions. If, let's say, it said cosecant theta equals 2, you would rewrite that as sine theta equals 1/2. right? Because really what this is saying is 1 over sine theta equals 2. So by rearranging it, you will get sine theta equals 1/2, okay? All right, so these are basic trig equations. Let's do something we haven't done before, which is solving by factoring. So let's look at this first one. Does this look kind of familiar to you? It should do. This looks like a quadratic. Now, when you look on delta, the way that delta will solve these is they'll do something like this. They'll say, okay, let cosine theta equal u. And basically they'll sub a u in everywhere that there's a cosine. And then they'll sub it back in at the end. I don't think you need to do that. If that helps you, like, you can use that method, no problem with that. But I'm just going to do it without substitution. Okay. So we're going to factor this out, right? Like you would solve a regular quadratic. It's already set equal to 0. We're going to multiply to get 3, add to get -7. So it's going to be -3 here, -1, 2 cosine theta, right? -1 times -3 is 3. 2 times -3 is -6. 1 times cosine, this will be -1, so it'll be -7, and then that'll give me 2 cosine squared theta. Then you set each of these individually equal to 0, so 2 cosine theta minus 1 equals 0, and cosine theta minus 3 equals 0. And then we have kind of the same situation that we had above up here, right? We're going to get here cosine theta equals 1/2, and cosine theta equals 3, and then we'll solve these. Well, cosine theta equals 1/2, when does that happen? That happens at 60 degrees. And it happens at 300 degrees, right? I'm kind of assuming that like the range restriction of 0 to 360, and then cosine theta equals 3. Well, when does that happen? Well, never, right? Because 3, I mean, this is 1 right here, so 3 is all the way out here. That's nothing there. So the only two solutions would be 60 and 300. Okay, let's try another one. This one's slightly different. We have, instead of it being more like a quadratic, this is kind of like a mixture, like take out the greatest common factor style question. So let's do that. The greatest common factor of these would just be a cosine theta. So we take cosine theta out, and then we would have 5 sine theta plus 2 equals 0 left over. Right now we have that product of factors, and we can set each one individually equal to 0. Cosine theta equals 0, so that means theta would equal 90 into 70. And then 5 sine theta plus 2 equals 0 would be sine theta equals -2/5. That's not on the unit circle, so that's something we would use our calculator for. -2/5. So that is -23.58 degrees. No, let's keep it consistent. Let's keep it within. Let's keep it within 360 degrees. So if I add 360, that would be 336.42. 336.42 degrees. And let's think about this visually. So we're saying that right here is where sine is -2/5. So if it's right here, then it also must be happening across on the other side over here, right? So what's that? That's going to be 180 degrees plus that reference angle, 23.57. So 180 plus 23.57 is 203.57. Okay, that's it. Got it? So on the test, what can you expect? No weird values. So basically everything on the test you can find on a unit circle. I'm not going to give you values beyond that, okay? Everything will be on the unit circle. You won't have to, you won't get a graphing calculator, so you won't be able to evaluate those, right? So here's the last kind. We have solving using trig identities. So it's just like a combination of these solving by factoring problems mixed with kind of what we've done this unit. We need to convert these problems so that they can be solved using factoring, okay? So to solve using factoring, if I want it to be a quadratic, I need to have like the same term throughout. So here I have a mixture of cosine squared and then a sine, right? Well, what's easier to do here? It's easier to convert from this cosine squared to the sine, so then I can then evaluate it, right? So we have 1 plus sine theta equals 2, and then cosine squared theta would be 1 minus sine squared theta. We're just going to rearrange things here, and we're going to get this would be 2 minus 2 sine squared theta. And we would get 2 sine squared theta plus sine theta minus 1 equals 0. Let's factor this. We're going to get 2 sine theta minus 1, and then sine theta plus 1, right? This will multiply to get a negative 1, and this will add to get the 1, and then we're all good, right? This equals 0, so then we say we're going to set those equal to 0 individually. Sine theta equals 1/2, and then sine theta equals negative 1. When does this happen? Well, sine theta equals 1/2 at 30 degrees and 150 degrees, and sine theta equals negative 1 at 270 degrees. Okay? All right, that is an example with a Pythagorean identity, subbing in to make it a quadratic. Here we have we can't use a Pythagorean identity. What can we use here? We can use a double angle identity. So for sine 2 theta, we don't have a choice. There's only one double angle identity for sine 2 theta, and that is 2 sine theta cosine theta minus cosine theta equals 0. And now here, I know we didn't make it a quadratic trinomial like on the left side, but that's okay. Because here, it's similar to this problem right here where we take out the greatest common factor. We kind of made it look something like that, right? So we're going to take out the cosine theta out of both of these. And then, sorry about that. Let's take out the cosine theta out of both of these, and then we'll be left with 2 sine theta minus 1 equals 0. And then same thing, we're going to set each of those individually equal to 0. Cosine theta equals 0. And then this will be sine theta equals 1/2. I'm setting that equal to 0 and then adding 1 dividing by 2. When does that happen? What's the same as over here, 30 degrees and 150 degrees. And then when does cosine theta equal 0? That happens at 90 degrees and at 270 degrees. Okay, and that's it. So kind of 3 sets of problems. We have the simpler linear ones. Get the trig value alone, take the inverse of both sides. You got it. Like, look at the range restriction. You have solving by factoring, which is kind of a mixture of factoring plus that, where you kind of treat the cosine squared and cosine as like an x squared and an x. You find the factors, you set those individually equal to 0, and you work your way down like that. Maybe you take out a greatest common factor. And then you've got the harder problems, which are a mixture of that, and then also using the trig identities. So making it a trinomial by converting that to 1 minus sine squared, or taking out the greatest common factor by converting a double angle identity into 2 sine theta, cosine theta, take out the cosine theta. Hopefully that makes sense. Good luck with the work today, Delta. And then after that, you should get your practice test today. All right, guys. See you next time.